Thank you for coming to my talk today. GitOps, the best thing since DevOps, but what's missing? Bit of a clickbait title, I know, but it got you here, that's the main thing. Actually, I think GitOps is okay. And what I'm going to talk to you about is what they don't tell you in those blog posts and conferences. The truth may surprise you. First of all, a bit of housekeeping. I just want to thank the sponsors for ponying up the cash for us to all come and listen to these talks today. Without them, we wouldn't have a lovely place like this to talk in. Also, there's the sponsor bingo going on, as was mentioned at the start. Go and get your lanyard stamped by the various sponsors, and you can win one of these great prizes. Awesome. So with that out of the way, and I'll just apologise in advance. For those of you with kids, you probably understand this. My youngest has just started daycare, so I'm starting to come down with some sort of God knows what disease, so throat's a bit funny. I'll be drinking a bit as I go through this. So what am I talking about today? So first of all, we'll start up by talking about what is GitOps. What the background of it, where it came from, and kind of why it's so useful. How many people here are using or think they're using GitOps in some capacity in their workplace today? Cool. A few? Maybe. We don't know. That's cool. If you see me walking around through the place today, reach out. I'd love to talk to you and sort of get to understand how you're using, because everyone kind of uses it in a different way and sort of hit some of these limitations. As we do that, I'll go through a sample project. I'll do a bit of a demo. I'm going to keep it fairly simple. I don't want this to be a lesson on Kubernetes or Argo. It's just to kind of highlight some of the principles here that I'll be talking about. And as we do that, I'll talk through some of these limitations that you will hit when you're sort of using it for real. So first of all, who am I? Why are you listening to me? Why do I have an interest in this space? So my name's Robert Erez, principal engineer at Octopus Deploy. I've been with the company for about 7, 8 years, depending on how you count, as a principal engineer. And so my interest in this space is kind of twofold. First of all, as an engineer, building and maintaining projects that kind of we need to deploy, and so thinking about how we can use GitOps to sort of get that process moving. But also, as an engineer at Octopus, I'm working on a team where our primary focus is on improving Octopus so it works even better with the way customers are using it in sort of modern deployment systems today. And GitOps is one of those sort of processes or tools. So over the past kind of year or two, we've talked to dozens and dozens of customers that are using GitOps in various ways. And doing that has given us a really good insight into kind of what some of those limitations are that you might not necessarily realize if you're squirreled away in your company building it. A single process that you come out and go, this is GitOps, this is the best way. Before that, I worked at Microsoft for a while on a team that we did some of the sort of early continuous delivery systems into Azure, kind of working against the cab mindset Microsoft had at the time. And a little interesting story about that. Is anyone here from New Zealand at all? 1, 2, okay, a couple. So I'm sorry to say that you'll probably find that quite often with SaaS companies, they'll use New Zealand as the canary in canary deployments. The reason for that is a couple. First of all, they hit the time zone first, so any of those pesky date time bugs, they'll get hit first. Secondly, they're English speaking, so bug reports and things are easy to sort of understand for English speaking engineers. And thirdly, it's a fairly small sort of contingent, so when things break down, it doesn't affect our stats too much. So no one really cares as much if New Zealand goes down. So yeah, sorry about that. All right, so what is GitOps? GitOps is an operational framework, and it's based on DevOps best practices. So take a step back for a minute. For those of us who've been in the industry for a while, you probably remember, back in the day, the way you'd sort of deliver software is you'd compile it on your machine, you'd copy it across, or RDP it across, or SSH it across to the production server, and you dump it there. And then you'd probably have a config file, and you rename the old one appconfig.old, and you probably have opconfig.old.old, and appconfig.old.deleteMe. And that's kind of how you shift it out. Or you throw it over the fence to the ops teams and you go, good luck, let me know if there's a problem. And we kind of realized that that wasn't really the best way of deploying software, right? So this whole idea of DevOps started coming out. And DevOps is all about sort of bringing those two teams a little bit closer, right? It's about bringing that relationship between the developers and the ops teams and solving a lot of those problems in a common way. And so it brings out these concepts of automation and continual improvement. And it's made that landscape a lot simpler. And a lot of tools have come out in the space to sort of leverage that. GitOps is the next evolution of that. So it's primarily come out of sort of the Kubernetes space, particularly, Kubernetes is kind of won the containerization orchestration battle. And it's really built on, declarative YAML, declarative configuration. And we're all engineers, we know what we do with configuration files, we stick them in Git. And so having this kind of mechanism of configuring your infrastructure has kind of led to this idea of GitOps and combining DevOps processes in a way that allows the ops team to really manage and deploy their infrastructure. It was introduced in 2016 by Weaveworks as a term. The process itself had been around for a little bit before that. But that's kind of its beginnings. Where it kind of differs from DevOps, however, DevOps, every blog post and every person you talk to will have a different kind of idea of what DevOps actually is. The original founders of GitOps, though, kind of got together and decided, what we need is sort of to set up a few key principles so that way it's very clear what is and isn't GitOps. And I think that's kind of got its pros and its cons. And this is their 4 key principles. So this is their words, not mine. So declarative, and I love this first definition, right? A system managed by GitOps must have its desired state expressed declaratively. There's nothing better than a definition that uses its own word in the description. So what is this actually saying, right? So this is saying what you want to do is you want to take your state, your desired state, and put that into configuration, into your code. And it's about basically defining the state that you want the system to be in, not how it gets there, right? So it's not about being procedural. It's about purely the what, not the how, right? And this is kind of powerful, right? It makes it a lot easier to understand what your system is going to look like. And anything that makes it easier to understand means you're going to reduce risk, and it's easier then to iterate on because it's very clear what the state should be. The next point, versioned and immutable. The desired state is stored in a way that enforces immutability versioning and retains a complete version history. So this is basically just saying you want to take that declarative state and put it in a store somewhere. And you want to put it in a store somewhere that has versioning and doesn't change, right? And the most obvious one for that is Git, and that's kind of where that Git part came from. And this is kind of nice as well, right? This means it's, in theory, and we'll see a little bit later why it might not be the case, but in theory, it makes auditing a lot easier, makes it easier to sort of perform rollbacks, things like that, because you've got this single source of truth. So those first 2 points are really quite obvious and clear why that's quite powerful and they're quite useful. And they kind of really shape the idea of what GitOps is about. Right? It tells you kind of what is a system that sort of conforms to GitOps. The next 2, I think, are a little bit more kind of wishy-washy, debatable. And it's really talking about some of the outcomes, I think, of GitOps and some of the ways you kind of implement it. So pulled automatically. Now, this is an interesting one because I think pulled automatically is kind of really a semantic discussion. So this is the idea that you've got a software agent. So this might be Argo CD or Flux if you're using it at the moment. It's this idea that those agents are pulling that state from your store rather than having it pushed. And that's kind of nice in some ways, right? So by having a pull-based mechanism, you can put all your sort of permissions and security concerns sort of upstream, rather than putting your configuration down in your repos about how to push to a different production servers. On the flip side, sometimes, depending on your network topology, it might not make sense to be pulled. You can imagine if you've got thousands of clusters and they're all trying to pull state, you might get some networking issues there. So I think this pull versus push semantic is at the moment, there's actually some discussions going on about what a push versus GitOps model kind of looks like, and I think that kind of talks to the fact that this point is maybe not the most important part of this. The fourth one, continuously reconciled. I think this kind of talks to, more broadly, sort of the outcome of GitOps, right? It's this idea that you've got these agents that are watching your desired state, they have knowledge and access to the actual state, so let's say it's Kubernetes, and they're continuously trying to keep those things in alignment. And a really good sort of diagram that describes that, I think, is this one by CodeFresh. And you can kind of see this loop, this reconciliation loop. So this talks to that idea that you've got the desired state, you've got the current state, and your agent is kind of this thing that sits in the middle that ensures that if the desired state changes, it's observing that. If the desired state changes, it sort of adjusts the current state to bring it into alignment. And that could happen for a couple of reasons. It might be that you've pushed a new update to your repo, so now your desired state's changed, so it's watching that, and it adjusts the current state, puts it back into alignment. The other one is what is often called drift. So this is where maybe an ad hoc change has been made to the system. Someone's logged in and removed a pod or added a new pod. And so your agent looks at that and goes, oh, that doesn't look like the desired state, I'll bring it back into alignment. And this is one that a lot of vendors talk about, how great it is they manage, and I'll talk about why I think that's maybe kind of overstating it, but we're missing the forest for the trees, that drift problem. But let's have a look at a bit of a demo, right? So hopefully, unlike Julie's demo this morning, this actually works. And like I said, I'm going to keep this fairly simple. It's going to be very much a cut and paste affair. You probably don't want to see me sitting here writing hundreds of lines of YAML. We'll be using Argo, which is kind of the most common sort of GitOps tool in the space at the moment, and Kubernetes. And so what we're going to do first of all is set up a hello world kind of scenario, right? This is the sort of thing you probably see in all the blog posts saying that if you've done this, then that's kind of your GitOps. Now go and put everything into this format. So I'll push this through and I'll have a bit of a talk about what we've actually got here. Hello world. Awesome. So this is a fairly basic deployment manifest. Again, it's not too important on the details. What we want to look at here is we've got this image, this Nginx image. Sorry, what was that? Ah, sorry. Okay. How's that? Bigger? Awesome. Okay. Cool. Yeah, so what's important is we've got the image, which is an Nginx image. This is what we're deploying, so this is just an image that's going out. And I'm just dumping in some static content so we can kind of have a look at sort of how it changes. So to get that to be kind of GitOpsy, you know, we've got our declarative code that's been controlled by me and the IDE. We've got our part of it that's versioned and mutable. It's now in GitHub. And so now we want to sort of get that pull-based semantics working. So we'll use Argo for that. So we'll create a new app, edit as YAML, and let's see, here's one I created earlier somewhere. Oh, cut and paste. This is the best way to program, right? Take that. So what this is doing is basically saying, here's the URL of the repo that I'm going to be pulling from. So this is one that I just pushed to. We give it a path. So the path is important, particularly when you're doing, you might have multiple environments or multiple projects in that same repo. And target revision is basically just the branch. So again, depending on what way you're doing environment progression, this may point to a different thing. By default, I'll just use the default branch main. And the second piece is where is it going to? So you can see this is kind of looking at those two desired and actual sort of states. At the moment, I'll push to my local cluster because the less I'm touching the outside world for this demo, the greater chance things have of actually working. And we'll create that. Awesome. I know what I did. This was a user error. Move to. I don't even know why I'm putting comments in there, to be honest. It's not going to matter. Let's try that again. Awesome. Okay, so we've got our Argo application up there, and what it's going to be doing is it's going to pull the state out of GitHub, go to my local repo and push it here. So you can see it's created the pod. And this is a really nice kind of view on top of it. So if we look at my local instance, awesome, it worked. Boom. So this is really kind of that intro hello world sort of scenario. So this is what you get when you go to the blogs or people are talking about in the conferences. You do this and this is now GitOps, and that's great. But I don't know about you, but I'm not sure there's many companies that basically just deploy Nginx static applications, right? You're probably actually trying to push something that you're building. So this is not quite realistic. This is kind of the hello world. So let's go back. Let's make it a little bit more realistic, right? So we want to have an actual application that we're building and pushing out there. So let's go back. What we're going to do is step 2. And I've noticed that the GitHub ID has a bit of a problem when you try to overwrite files. So I have to do this hacky thing. I'm actually going to basically cut and paste what I had. So what I've basically done, actually I'll push it and I'll talk about it because it's going to need to do some more stuff. So let's go more real world. Awesome. So what we've got here, I've taken that deployment manifest and I've broken it up into 2 pieces. That makes it a little bit easier when I'm trying to update it later in a minute. So we've still got that image. In this case now, this image is going to be based on one that I'm building as part of this process, and it's going to be pushing to GitHub's package repository. We've got a really simple Node application. I'm sure this perfectly mirrors advanced applications you guys are all building today. Packages it up into a Docker image. And then the other interesting piece about this is we're using GitHub Actions to basically build that image. Actually, we'll go to the actual action. Let's see if it's running. Awesome, it's already done. So if we look at what it actually did, it builds the image and pushes it to the GitHub repository. And then it does this other interesting thing, right? So this is where it starts going from CI to touching into the CD part of things. What it's actually going to do is check out the repository. In this case, it's itself. I'm basically going to, we'll check out the repository. I'm then going to access that deployment manifest and update the image that it's got stored in there, and then push that back, such that what you'll end up seeing on the actual, in the code itself is, you can see this new commit that's been added by the GitHub action that's pushed it. And so now if we look at Argo, it, in theory, if it's done its job, has just triggered. Yep, so you can see move into folder was the one I just pushed. And awesome, hello from Node. So that's kind of nice, right? But having it all in the same application, it starts to get a little bit unwieldy, particularly when you're doing things like environmental progression, etc., in which we'll touch on in a second. So what's slightly more real world, again, is to actually separate the two. So what you want to do is separate your manifests and your sort of GitOps content from the actual applications itself. So to do that, we're going to basically just delete a bunch of stuff. And again, here's one I created earlier. I've got a separate repository here. If you can see, basically it's just dash app, something slightly different. But the contents of it are pretty much the same. I'm pushing a Docker file. It's got a build process, which updates that original repository. Just to trigger it to run, I'll make a change here. Live. Put some exclamations. Why not? And what we'll see happening over in that repository, we'll see that job kick off. So that's now running. And when that runs, what that's going to do is, similar to before, build the image, put it into GitHub's package repository, and then at the same time, or just after, reach over and update the image that's sitting over in our other repository. So let's just see how it does that. Again, no doubt there will be no delays or failures. And this is kind of quite nice now. We've got this separation, right, so that the application team can build and iterate on the application, and it's very clean and clear where that separation occurs between application and your infrastructure manifest, etc. So in theory, if we look over here, so we can see that new one has been pushed, and let's see what Argo is doing. So by default, Argo has this. So when we talk about that pull mechanism, Argo has this default. I think it's at 3 minutes, where it's polling constantly, and because it's trying to pull. And this is one of those differences between pull versus push, right? If it's a pull-based mechanism, it typically means that that agent upstream is doing a poll, and so it's occurring whenever that kicks in, whereas a push-based mechanism would be kind of immediate. And so it's just done that update. So I've updated it locally to run every 10 seconds just to make this a little bit quicker. In theory, that'll all work. Let's see what happens. Awesome, works. Okay, so what have we ended up with? So we started with that really basic configuration where we had a single repository and we were using Nginx and we had no complexity. And now we've got something that's slightly more real world, right? We've got an actual application repository. We do the builds in there. It pushes an artifact. And then we've got a separate repository, separate part of the system that deals with the CD side of things, right? It's the part that deals with your manifests and your deployments. And this is kind of important, right? Because CI is not CD, right? In CI, what you're concerned about is things like running tests. It's for generating artifacts. You might run hundreds and hundreds of them, those chains per day, per hour. Whereas CD, what you're interested in is things like environments and potentially secrets and deployment locations, etc. And having them separate kind of makes that a lot easier to manage. So, and we'll go through a couple of these GitOps realizations, and I put the asterisks here because ultimately these are not kind of, I'm not going to come here and say these are the rules that you kind of have to do or you're not doing GitOps. These are just some sort of realizations that actually, we can hold GitOps in a way that works for us. So this first GitOps realization is that the source of truth doesn't need to be in a single repository, right? And as we saw that, we've got 2 in this case, and depending on how you configure things, you can end up with a whole bunch more, and that's okay. So that's cool. We've got our application now, and we're deploying it, and that's all great. But we want to actually use it to integrate with some third-party system. So how do we get secrets in there, right? And I'll talk about this in the context of Kubernetes, because this is where a lot of this comes from. So in Kubernetes, when you want to get a secret in there, it's got this concept of a secret resource, right? So how you get that secret in is you base64 encode your password or your certificate or whatever it is. You put it in a secret resource, and then you want to get that resource into the cluster. So again, we're engineers. We know what we do with files with resources in them. We stick them in Git. Hopefully, as I've said that, though, you've kind of realized that maybe that's not a great idea, right? With base64 encoding the value. You probably don't want to put base64 encoded values just straight in your repository. That's not really protected at all. It's like going to the shops, locking your car and putting the keys on the hood of the car. It's not really security at all. So one way that's come along to try to solve that problem is with what's called sealed secrets. This is a little bit better. In this scenario, we generate a public and a private key. We put the private key into our cluster. We take the public key and we start encrypting these secrets. So now we're not just encoding, we're actually encrypting them. and we put that encrypted value in a sealed secret resource into our repository. Great, it's secure. I want you to have a think, though, about how encryption algorithm security has changed over time, and also how the very core value premise of Git is it's a store, an audit store of everything that's changed forevermore. So you now have to accept this risk that sure, it's encrypted, but in future it might be able to be decrypted. Or it's still encrypted, but now potentially anyone on your team has access to it. And you might say, yeah, Rob, but it's encrypted, it's fine, encryption's good, it's secure. I'd be interested to hear if you explain that to your customers, right, or your clients, that you've taken something that's giving them could be the keys to their kingdom, and putting it out somewhere that anyone can access to, but don't worry, we've secured it. They probably would still ask, well, why are you even doing that in the first place? From a more practical point of view, sealed secrets make things a lot harder when you need to do things like key rotation, right? So if you've got multiple environments, you're probably going to have multiple public and private keys, right? Because you want different security boundaries for each environment. So you're now going to need to manage a whole bunch of keys yourself. And when you want to rotate them, you're going to need to work out, well, how do I regenerate those sealed secrets? You're going to probably do that in one of two ways. You're going to either go and regenerate all those actual secrets that you've got with your third-party tools, right? You might go and regenerate your Azure keys and regenerate everything and use your new private key, public key to store them. You're probably not going to do that. That's probably a lot of work for across everything all at once. Or you're going to have those secrets already stored somewhere else, and you're going to go and get them and regenerate them, re-encrypt them again, right? And that's kind of okay, but I suppose it kind of moves on to the next point of if you've got those secrets already somewhere else, why not just use that, right? Because now what we're talking about is you've got multiple sources of truth. So this is where external secret operators come in and kind of make that a little bit simpler or solve that problem. So in this world, we take the secret, we put it in Azure Key Vault, Azure Key Store, Key Vault, whatever it is, and instead we store a pointer to that. We put that into an external secret resource, get that into our cluster, and the external secret operator has the credentials to reach in and sort of convert that pointer to the actual secret. And that's great. We've solved that problem. But now what we've actually done is we've kind of moved some of those parts of our system outside of Git. And so you might look at that and go, well, hang on, we're not doing GitOps anymore. We're not having everything in Git. What's happening? This is not GitOps. And sort of, I say to you, no, this is still GitOps. So if we look back at some of the core principles of GitOps, one thing you might notice is missing there is any mention of the word Git, right? Apart from the name, ironically. The truth of the matter is, ultimately, the source of truth doesn't need to be exclusively in Git. And this is something that some of the founders or some of the initiators of that Open GitOps movement have even come out and said that was a very deliberate choice to not put Git into any of the descriptions there. Ultimately, it just needs to be somewhere which is a store that you can put your declarative information that is versioned and immutable, which is good, but it's then kind of a bit funny and ironic that they called it GitOps. But I think that was kind of more of a marketing push than anything. So that's great. We've got our secrets. Now we kind of want to have environmental progression, right? We've done our work in dev. We want to get to production. How do we do that? So one of the first ways, one of the most, the original ways we kind of did this was branch per environment. And this kind of makes sense, right? As engineers, we're kind of used to this idea that our feature branch is kind of not quite ready for production. So we do our work in there. It's dev. We do whatever we need. And at some point, we merge it into master or main or the release branch. And that's kind of our representative for production. And so it kind of made sense that we'd use a similar model for environmental progression, right? We'd have our configuration stored in a different branch that matches each of our environments. And progression or updating an environment involved sort of merging between them. Unfortunately, this has a bunch of downsides, right? It creates a big risk of drift. At the end of the day, this is still they're all just different Git branches. There's nothing stopping anyone from coming in and just updating staging directly without having changed QA or updating production without touching anything else. you can use some branch protections that you might have in your Git repository, but ultimately you're kind of working at the whims of what your provider has. You've also got the increased risk of merge conflicts. So when we make a change to staging, we're probably going to be putting it in a config file with the same property name as the production version of that value in the production branch. And so let's say you go along and you update the URL for your staging, third-party staging resource in your staging branch, and you go, sweet, that's in there. When you then go to merge that to production, whoever's hitting that merge button now needs to understand the context of that change and know not to overwrite that production value of that variable. And so that makes it really difficult for automation, which is kind of one of the key principles of DevOps is all about, automate, automate, automate. What this process makes it really difficult to do is to automate that, because you need some kind of knowledge of kind of the structure of how everything fits together. Rollbacks are a little bit unclear. You can imagine you've made a change to production, it's failed, and you want to roll back. Which commit do you roll back to, right? If you made 20 commits to staging before you merged it, it's not necessarily clear what it means to roll back production. You can use tags and pointers and things like that to manage that, but now you're starting to actually talk about building things outside of Git, which is kind of my point, but then kind of going against why you'd even do this in the first place. You've got scaling problems. This is fine with 3 branches, but what happens when you've got a dozen test environments and you got multi-tenancy, so maybe you've got 20 different tenant branches as well. Managing that whole progression and ensuring that you're kind of avoiding all these risks become quite risky. And there's a permission problem. As I said, you're kind of beholden to whatever your Git provider will allow you to sort of control. It's hard to manage to make sure that the people who are updating QA don't have access to just start making changes to the production variables. So another way of dealing with this is repo per environment. So this is this basically moves, instead of putting these configuration differences in across your branches, you put them in entirely different repos. And that kind of solves a permission problem, which is nice. But you've still got risks of drift, right? This is still Git. There's nothing stopping someone from coming in and just changing any one of them outside of the bands of standard progression. You've still got scaling problems, except now instead of 100 branches, you've got 100 repositories. And you've got the progression becomes a little bit more interesting, right? So what is progression in this space? Well, you've probably built this whole tree of forks and merges between forks. And as soon as you want to make any change to that structure, it starts becoming really difficult. What's kind of become more standard now, and tools like Customize really lean into, is folder per environment. And so in this mechanism, your environment-specific details are stored in different environments in the repository. And so in Customize, they're kind of called overlays. So you can imagine you might have a bunch of variables for staging that differ from a bunch of the variables in production. And then you'll have a base configuration that kind of sits above that they overlay on top of, and that's how you kind of get the separation of environments. Unfortunately, you've still got a lot of the same risks, right? You've still got a risk of drift. Again, there's nothing stopping anyone from coming in and changing configuration in any one of those environments. It's worth pointing out actually as well, with this model, typically your agent, say Argo, would be pointing at, say, master or mainline branch. So you kind of, in this world, dealing with effectively one branch is the source of truth for each of the environments. You've still got risks of merge conflict. So again, imagine you've made some changes to your staging environment. Some of those changes are very staging specific, and some of those changes are a new value or variable because you've added a new feature. Now, when you do that merge, whoever's merging that needs to understand the difference between am I merging something that's kind of important to progress because it's actually correlated to that code that's moving between environments, or is it something that's just staging specific? So again, it makes that automation really difficult to do without sort of complex. I've seen some vendors have sort of complex JSON path schemas that allow you kind of to pick and choose what is and isn't supposed to change between environments. So it's all doable, but just difficult. Auditing becomes complex. So again, one of the key concepts of GitOps is it makes auditing simpler, right? Because you got everything in Git, that single store. In this world, though, the changes I'm making to staging are kind of in the same branch and the same repository as all the changes I make to production. So it becomes really difficult to really tease out what are those changes that have gone out into production now that have affected it. You're probably going to need to build a system on top of it to kind of pull all those pieces out and put the picture back together so you actually understand what's changed. So what's the answer to this? Well, I kind of like to go back to one of the concepts that kind of we as application engineers have kind of known for a long time, right? Back in the old days, again, we used to have, app.staging.config and app.prod.config, and we had them all in our code. And we learned that that's not really ideal, right? And the 12-factor app, I don't know if any of you have read that, go and check out their website online. They list a whole bunch of concepts that make for a really safe application. One of them is configuration. So this is the idea that you want to separate your code from your configuration. Config varies substantially across deployments, code does not. And we've learned that and known that in the application world for a long time. And for some reason, now that GitOps has come along, and I think a lot of the sort of ops engineers that are kind of coming along for the ride have kind of forgotten this core principle, right? And so I think it's important to keep in mind that really environment configuration doesn't need to be, and in fact I'd say shouldn't be, in Git. What you end up is with YAML sprawl, right? You can imagine a complex application with 100 different branches, 10 different environments. You've got a bunch of YAML there you need to maintain, and that's for each application. So every application you do kind of compounds on this. So again, it's all doable, but why do it? The other thing is Git-only workflows really impede automation. So, as this lovely meme says, Git's not a general-purpose database, right? I could model Git in SQL Server if I wanted. I could probably build a system that would use SQL Server as my background for Git. And in fact, I think, if I remember correctly, I think VS Code at one point in the past even did that. And that was horrible idea. You wouldn't do that, right? And I think the same can be said for Git itself. Like, don't use Git as just a general-purpose database. That's not what it's for. I'll talk to you now a little bit about drift detection. I couldn't think of a good bunch of text to put on this meme, but I thought it applies. It's drift. It's funny. So this is not, what I want to talk to you about is not that drift detection is bad. It's just that I think it's kind of missing some of the key points, missing the forest for the trees. It's missing the point of what you should really be focusing on. So if we look back at that continuous reconciliation loop, we've got the desired state. We check the desired state aligns with the actual state. When it drifts, our tool sort of brings it back into alignment. What often some people will do in the real world, though, is you have some change you need to make. So you'll go in and you'll just make an ad hoc change to your cluster. And obviously, if you've got your tool turned on with drift detection, it'll kind of just wipe that away and reapply it. What's funny is that tools even offer this as an option. And this is actually even called out in the Open GitOps document, manifesto. They say that it's common practice in Kubernetes to make ad hoc changes. And so the tool should manage that. And I kind of question that whole premise, right? Ultimately, really, if you're kind of relying on these ad hoc changes being made to your system, you're kind of missing the point. You're missing really the problem that's actually there. Like, why even allow those ad hoc changes to take place? I like an analogy that I heard, which I think kind of is quite nice. Imagine you're running a factory, and you've got a bunch of guards that sit out the front to make sure people don't break in. Once they get through the fence, break into your factory. And when they do it once, it happens once. Someone gets in, the guards grab them and throw them back out behind the fence. You think, great, they've done their job. I'm glad I've got the guards there. If that's happening on a daily basis, and you've got the guards there because it's happening daily, and that's the mechanism to keep people out, I think you need to start asking some more sort of serious questions about: do we have problems with the fences? Why are people even getting in the first place? And I think the same can be said here for drift detection. It's not that you want to get rid of the guards; it's just focus on why that's even a problem in the first place. So really, what you need to be doing is using tools that allow you to interact with your cluster in a way that's a little bit less ad hoc, managed and audited properly. So that might be through Octopus, for example, has runbooks, or with some other tools, you can actually run them directly from the tool itself, and it's audited and controlled. So this is the fifth realization there, that drift detection shouldn't be relied on for standard business practices. So it's not that it's not useful to have it there, But if you're relying on it to do your day-to-day tasks for making ad hoc changes, maybe have a bit of a think about other ways of handling that. So, in summary, what have we talked about today? So, GitOps is good, right? So as I said at the start, those principles are really useful for sort of simplifying and understanding what it is you're sort of deploying, what the system looks like, reduces risks, if done properly, makes it easier to sort of do auditing and do rollbacks, etc. But I think the important thing is you should be leveraging the right tools at the right time. And Git is not necessarily the right tool for everything. So again, I don't want to make this into a sales pitch, so Octopus is one example, but there are a lot of other ones out there, whether it's kind of CodeFresh or Harness or anything else that kind of sits on top of your system and provides whether the environmental controls, etc., that you need. I think part of the problem ultimately is kind of the name GitOps. And actually talking with one of the engineers who was at WeWorks at the time, he kind of admitted that the name was perhaps not ideal, but it worked really well from a marketing perspective because, you know, Git everything is kind of quite a big trend at the moment. I think if instead of GitOps it was kind of called StateOps, a lot of these problems wouldn't exist, right? Because I think people hear GitOps and they read a couple of blog posts and they get really dogmatic about it, right? They go, if it's Git, then it's GitOps. And if it's not Git, then it's not GitOps. And I think if you look at those core principles there, the reasons that they're there and the problems they're trying to solve, you realize that doesn't need to be the case, right? Talking with a lot of customers recently, when you're actually discussing, you know, teams, platform teams that are trying to deploy to for hundreds of applications, for hundreds of teams, they don't really care what you call it. They're just trying to solve these problems, right? And so hopefully if you do that and you're using the right tool for the right job, you can avoid YAML sprawl turning GitOps into GitOops. And I realized as I did this slide, I didn't really have an answer for what's left out, you know, what's missing from GitOps. I think really what's missing is it's not the what's missing, it's what's there that what shouldn't be. And I think it's that over-reliance on Git. So basically, yeah, think about what you're using, what the tools are there for, and hopefully you kind of have better success. Thank you for listening.